Throughout the history of science, people have tried to understand how the universe began. The most common explanation has been something called the Big Bang Theory. Many studies and the work of thousands of scientists support this idea, providing evidence about how the universe started. However, in today's world of science, new technology brings us new ideas and perspectives. These ideas challenge what we once thought were unquestionable truths. Neil deGrasse Tyson has become an important figure in this changing world of science. Now, something exciting is happening with the James Webb Space Telescope. It's revealing something that might make us question the Big Bang Theory. The James Webb Space Telescope has found 750 new galaxies. These galaxies are different from what we expected, leading us to rethink what we thought we knew about them. This telescope was designed to help us understand how galaxies came to be, so it's not surprising that it's shaking up our understanding of the universe. In the past, scientists said that the Big Bang Theory was the best explanation for how the universe started. According to this theory, about 14 billion years ago, the universe came into being through a mysterious cosmic event, like the ultimate story of the universe's birth. But the images from the James Webb Space Telescope have challenged this idea. These images show galaxies that are smaller, smoother, older, and more numerous than what the Big Bang Theory predicts. According to the theory, as the universe expands, objects should look bigger the farther away they are, but these galaxies don't follow that rule. The theory also says that at the very beginning of the universe, all the stuff that makes up the cosmos was packed into a tiny superdense point called a singularity. This singularity was incredibly hot, hotter than anything we can even measure or create. This idea of a singularity comes from a set of equations in physics proposed by Albert Einstein called general relativity. Inside the singularity, all the stuff in the universe was squeezed into a tiny space with super high density, meaning there was an enormous amount of mass and energy packed into a tiny space. In simpler terms, scientists have always said the Big Bang Theory was how the universe started. But now, these new images from the James Webb Space Telescope are making us question that idea. The galaxies it found don't fit with what the theory predicted, and the theory's explanation of the early universe might not be as certain as we thought. In our current understanding of the universe, we believe that all the energy in the universe started from a super hot and super dense point called a singularity. This singularity is like the starting point for everything we see in the universe today. After this singularity, the universe began to expand and grow over about 13.7 billion years to become what it is today. The expansion started with something called cosmic inflation, where the universe grew incredibly fast, even faster than the speed of light. It's like the very fabric of space itself was stretching, and everything in it was stretching along with it. This cosmic inflation helped shape the universe by making things more uniform and setting the stage for galaxies, stars, and other cosmic structures to form. As the universe continued to expand, it didn't expand as rapidly as during cosmic inflation, but it still kept getting bigger. We call this ongoing expansion cosmic expansion. Scientists have seen evidence of this expansion through things like the way light from distant galaxies changes color, known as redshift. Now, let's talk about those amazing pictures of new galaxies taken by the James Webb Space Telescope. To most people, these pictures look stunning, with hundreds of galaxies in a single frame. But for scientists, it's a bit of a surprise. These images don't match what their theories predicted. First of all, these galaxies are much older than expected. This challenges what we thought we knew about how galaxies form and evolve according to the Big Bang Theory. Also, there are way more galaxies than we anticipated. The Big Bang Theory made predictions about how many galaxies there should be and how they should be spread out, but the JWST images show many more galaxies than expected. This makes scientists question whether the theory's predictions are accurate. Some scientists are even starting to panic a bit because these findings don't match their expectations at all. Another surprising aspect of these new galaxies is their smoothness, which goes against what the Big Bang Theory suggests. According to the theory, galaxies should exhibit irregularities and variations in their structures due to how they formed and evolved. However, the images from the JWST show galaxies that are unusually smooth, lacking the expected complexity and roughness. During the expansion of the universe, everything that makes up our universe was squeezed into a very small space. As the universe expanded and cooled down, changes occurred in particles like protons, neutrons, and electrons began to interact with light and energy around them. These interactions played a crucial role in shaping the formation of matter in the universe. In the first few minutes after the Big Bang, there was a process called nucleosynthesis, which involved the creation of lightweight elements like hydrogen and helium. These elements set the stage for the formation of stars, galaxies, and more complex elements as cosmic history unfolded. This synthesis of elemental building blocks was a significant step in the universe's evolution, transitioning from a primordial sea of particles and energy to a state where matter began to take shape. The Big Bang Theory had anticipated seeing galaxies that were jumbled and disrupted due to multiple collisions. However, the JWST images tell a different story. Instead of chaotic and disordered galaxies, the pictures reveal smooth disks and well-organized spiral shapes resembling the galaxies observed in the present-day universe. This unexpected finding challenges the idea that mergers are a common part of galaxy evolution. If there are very few or no mergers happening in these galaxies, as suggested by the Big Bang Theory, it becomes unlikely that tiny galaxies could grow to become hundreds of times larger. Additionally, the optical illusion predicted by the expanding universe hypothesis, where objects appear smaller with increasing distance due to expansion, doesn't seem to be present. Astronomers have observed a striking pattern where galaxies tend to cluster together in large groups, forming intricate networks across the universe. This observed large-scale structure aligns with the predictions made by the Big Bang Theory. According to the theory, the universe began in a super-hot and dense state and then gradually expanded and cooled down over time. As the universe expanded, gravity played a crucial role in shaping how matter was distributed and in lining up galaxies. The gravitational effects predicted by the Big Bang Theory are consistent with what we see today, with gravity pulling matter together, leading to the clustering of galaxies and the formation of interconnected filamentary structures known as the cosmic web. The presence of these galaxy clusters and the cosmic web pattern strongly supports the Big Bang Theory. The way galaxies are distributed across the universe aligns with the gravitational effects expected from the initial dense and expanding state proposed by the theory. All of these factors, including the clustering of galaxies, the cosmic web structure, and the distribution of galaxy clusters, provide strong evidence that the universe evolved from an extremely dense state and has been expanding over billions of years. Now, let's revisit the size of the galaxies discovered by the JWST. These images contradict what we thought we knew about the Big Bang Theory. According to the theory, small galaxies should grow and become larger through collisions and mergers with other galaxies. However, observations made by the JWST have cast doubt on this idea. If galaxies were colliding and merging as expected, we would see evidence of these collisions or dense interacting galaxies. But the images show something different. So, is the Big Bang Theory just a concept without evidence? No, it is actually supported by compelling evidence, including observations of the redshift of light. Evidence from distant galaxies provides support for the expanding universe theory. Observations showing galaxies moving away from each other in all directions suggest continuous expansion, as predicted by the theory. The abundance of light elements like hydrogen and helium found throughout the cosmos is also consistent with Big Bang Theory predictions. Additionally, the large-scale distribution of galaxies revealed through astronomical surveys matches the patterns predicted by the Big Bang Theory. One of the most significant pieces of evidence for the Big Bang Theory is the discovery of the cosmic microwave background, CMB. The CMB is a faint radiation that fills the entire universe and represents the afterglow of the Big Bang. This cosmic radiation, first detected in 1965, aligns closely with the predictions made by the Big Bang Theory. The observed characteristics of the CMB, including its uniformity and temperature distribution, strongly support the idea that the universe was once in an extremely hot and dense state before undergoing expansion. A central element of the Big Bang Theory, the discovery of the cosmic microwave background, is a crucial piece of evidence that offers us a unique glimpse into the early moments of the universe. It acts as an echo of the initial stages following the Big Bang and has played a vital role in solidifying the Big Bang Theory as our best explanation for the origins of the cosmos. However, recent findings have challenged some aspects of the Big Bang Theory. The existence of galaxies with ages that seem to predate the Big Bang contradicts the theory's fundamental premise, suggesting that the Big Bang may not have occurred as originally thought and everything may not have originated from it. Proponents of the Big Bang Theory had expected that as the James Webb Space Telescope looked further into space and further back into time, the number of observable galaxies would decrease, eventually leading to a cosmic dark age. However, recent research indicates that even a few 100 million years after the hypothetical Big Bang, galaxies as massive as our Milky Way were common. The JWST images reveal a much greater abundance of large galaxies at redshifts greater than 10 than what theorists had predicted, challenging the plausibility of the Big Bang Theory. Moreover, the Big Bang Theory is associated with 16 incorrect predictions in the current body of scientific literature, with only one accurate prediction regarding the abundance of deuterium, a form of hydrogen. Some of these incorrect predictions include estimates of helium abundance, which are off by a factor of 2, and predictions for the abundance of lithium, which are off by a factor of 20. The theory also fails to explain various phenomena, such as the absence of the anticipated illusion where objects should appear smaller with increasing distance. These inconsistencies raise concerns about the validity of the Big Bang Theory. By studying the colors of distant galaxies in the infrared part of the spectrum, astronomers can estimate the ages of the stars within these galaxies. Some of these galaxies appear to have stellar populations that are over 1 billion years old, contradicting the theory's assertion that nothing should have originated before the Big Bang. Despite these significant inconsistencies, it's noteworthy that the potential collapse of the Big Bang hypothesis hasn't received widespread attention in major media outlets. The lack of widespread attention to recent challenges to the Big Bang Theory can be attributed to what's known as the Emperor's New Clothes effect, where questioning the theory often leads to scientists being criticized or labeled as unintelligent, which can deter further exploration of alternative theories. The cyclic universe model, in particular, could potentially explain the new galaxies that have been detected. These galaxies might be part of a new cycle that we have observed. However, it's essential to note that these alternative theories have their own complexities and challenges, and the scientific community continues to explore and debate these ideas. The pursuit of knowledge and understanding in cosmology involves ongoing exploration and consideration of various hypotheses, and open discussions are vital for advancing our understanding of the universe. The James Webb Space Telescope, JWST, has provided astronomers with unprecedented views of the universe, revealing phenomena that could reshape our understanding of cosmic history. One of the intriguing aspects of these discoveries is the unexpected density and distribution of early galaxies. The presence of such an abundance of massive galaxies in the universe's infancy suggests that these structures formed much earlier than previously believed. This challenges not only the timeline but also the processes that were thought to govern galaxy formation. In addition, the JWST observations offer new insights into the conditions of the early universe. For instance, the telescope has detected signs of complex molecular structures in some of these ancient galaxies, indicating that star formation and chemical enrichment might have occurred more rapidly than the Big Bang Theory anticipated. This finding implies that the initial conditions of the universe might have been more conducive to the formation of galaxies and stars than earlier models suggested. Furthermore, the clarity of the JWST images is allowing scientists to study the interactions between galaxies in greater detail. This could lead to a re-evaluation of the role that galactic collisions and mergers play in the evolution of cosmic structures. The traditional view, which heavily relied on the Big Bang Theory, posited that these interactions were crucial for the growth and evolution of galaxies. However, the new data suggests that the early universe might have experienced a different dynamic, one that requires rethinking the mechanisms of galaxy assembly and growth. The presence of highly organized, smooth galaxies in the early universe could also imply that the processes governing galaxy formation were more uniform than previously thought. This could suggest that the universe underwent a more orderly and less chaotic development phase than the Big Bang Theory predicted. As scientists continue to analyze the data from the JWST, they are likely to encounter further anomalies that challenge existing theories. This ongoing research is crucial, as it not only tests the validity of the Big Bang Theory, but also opens the door to new theoretical models that could better explain the observed cosmic phenomena.